Okay, today we are going to talk about how to factor a second degree polynomial or a quadratic expression. It's written in standard form ax squared plus bx plus c by doing something that's called grouping, and I'll also connect it to the area model. Okay, so the first expression we're going to work on is 2u squared minus 11u plus 15. So I like to go through a little checklist as I'm doing this to make it easiest for me. First, I like to make sure it's in standard form. So that's all set. Next, I look at the expression and see if there's a greatest common factor that I can remove. Doesn't look like there is. Then, especially in this situation, I want to check out and see if it can be factored into, it follows the difference of two squares pattern or the perfect square trinomial pattern. Nope, doesn't follow either of those. And then if a was equal to 1, then that would certainly be easier to factor, but it's not. So we need to follow the grouping or area model version of approaching this problem. Okay, so what we know so far, if I'm trying to fill this in with my area model, is I can put 2u squared there, and I can put 15 here, and I know that these two boxes are going to have a sum of negative 11u. But I don't know what my full dimensions are going to be. And these aren't going to both just be u's this time. One will be a 2u and one will be a u. So I have to play a different sort of game than I've played in the past. I'm looking for two numbers that have a product of 30, not 15. So we're going to come back to why it's 30. And those two numbers are still going to have a sum of negative 11. Because I have this extra factor of a 2 in here, I need to consider that when I'm trying to come up with my two numbers here. So I'm going to do 15 times 2 to give me 30. So let's play that little game. Two numbers with a product of 30 and a sum of negative 11. Negative 6 and negative 5 are going to meet our needs, which means this must have been a negative 6u there and a negative 5u there. Now, using the area model, I can focus a little bit here. This dimension is going to be the greatest common factor of these two expressions here, these two terms. So it's just going to be u, which means that this must be 2u over here. So this has to be negative 3, and this has to be negative 5. So then to double check, these two areas have this dimension in common, so that must be a negative 5. These two areas have this dimension in common. Their greatest common factor is a negative 3. So if I write the dimensions of the entire rectangle, that's going to give me a 2u minus 5 and a u minus 3. Now, if we didn't use the area model, I can still come at this problem using the information that I have here. I'm going to take the way that I broke it down into my individual areas. I'll approach it like this. The original expression must have come from 2u squared minus 6u minus 5u plus 15. We are going to connect this back to the area model here. Where in this section, we're going to do something, this is where the grouping piece comes into play. I'm going to take this first pair of terms, and I'm going to find their greatest common factor. Same thing as finding the greatest common factor for this dimension here. It's going to be 2u. Then I'm left with Notice how that connects to our dimensions up here. 2u, 2u. U minus 3, u minus 3. Focus on the second group. So if I have the negative 5u plus 15, so this part here, I want to take out their common factor, which is a negative 5. I am again left with the u minus 3, which makes sense because the dimensions of this rectangle here are negative 5 by u minus 3. So I have this rectangle together with this rectangle gives me the entire rectangle. So I have this expression, and I'm going to factor out. They each have this common factor of a u minus 3. I take out the u minus 3 factor from this product. I must have a 2u left over. Take out the u minus 3 factor from this product, then I must have a negative 5 left over. And notice it is the same as what we got originally. But if we're coming at it this way, hope that makes sense. Have a great day.